afternoon, everyone. In today's class, I want to discuss on open and close pipes. Okay, last time we discussed on vibration in strings. So today I want to discuss open and closed pipes. Now let us see. A 40 cm tube closed at one end resonates at its fundamental frequency with a tuning fork of unknown frequency. If the end correction of the tube is this, determine the frequency of the tuning fork. Now, the speed of sound in air is given as 330 meters per second. So what do we do now? We have to draw the diagram. Let's see. This is the diagram. We have our tube. This is our tube, and it's closed at one end. So we have this. So from here to here is the end correction, E. From here to here is the length. So from here to here is the effective length. Now in that case, you have the tuning fork. We have the tuning fork here. This is our tuning fork. And the frequency of the tuning fork is unknown. Okay? Now, you know that this is antinode, this is node. The distance from antinode to node is 1/4 wavelength. Okay? So what to do now is this one plus this, E plus end correction plus the length is equal to this over 4. So the end correction, making this the subject, so I have 4 into E plus L. Okay? Our wavelength is given as V over F, which is 4 into E plus L. I'm looking for frequency, so my frequency will become V over 4 into E plus L. Okay? Now, our end correction from the question is giving us 3.2. So you have 3.2 cm. Divide this by 100, you have 0.032 a meter. Now the length is 40 cm. Our length is 40 cm. Divide this by 100, you have 0.4 meter. Okay. Now from the formula, you have F is equal to V into 4 into E plus L, which is our V is 330. You have 330 over 4 into our end correction is now 0.032 plus our L is, look at it here, 0.4. Okay? So by the time I add this and this, I'm going to have 330 over 4 times 0.432. So our frequency will become 330 into, this time this is going to give me this time this is 1.728. So by the time I divide this, if I divide this by this, I will get my final answer. So my final answer becomes, that is, this divided by this is 190.9 Hz. So this is my final answer. Now we've finally finalized this one. This can also be approximated to 191. Thank you.